Muhammad Chapu, for now, maybe it's better to mute yourself when I announce everybody. Then I say it's Muhammad Chapu turn, and then you can turn on your microphone.
Okay.
Hocam şimdi YouTube'da canlı yayındayız.
Hello everybody. Good afternoon to all of you. In this session, I am the chair, session 19. I'd like to first of all thank the organizing committee and thanks the staff for this valuable symposium. Today we are going to continue with the 4th International Student Science Symposium, which is held through Zoom meeting online and at the same time live on YouTube. In this session, we have in total 6 presentations. As a first presentation, it's going to be presented by Muhammad Chapu, and then it will continue with Gözde Turan. Following it, İzel Ok, Muhammed Nasif Abbas, and Said Zabut. And finally, we will complete this session with Shad Ali. Hopefully, all of the presenters are here, and hopefully you will enjoy this meeting. Before starting this session, I would like to remind you that you have to keep in mind that you have certain 15 minutes, including the question and comments time all together. Please try to be as much as precise on time. Since it's a virtual meeting, we have to be on time to move on. That's why please try to complete your presentation within approximately 12 or 13 minutes and let at least 2 or 3 minutes for the question answer parts. That's all from now on. Now I'm going to present Muhammad Chapu for his presentation. This presentation is going to be characterization of triple superphosphate for application in heavy metals removal. Welcome, Muhammad Chapu, and it's your turn. Start, please.
Good morning, sir. Good morning, everybody. Good afternoon, sorry. Good afternoon, everybody. I would like to take 1 minute. My supervisor wants to attend the conference. So he needs a link to attend the conference.
I think you can provide the Zoom meeting ID to him or her, as well as the passcode. Our Zoom meeting ID is 462-161-8453, and the passcode is 112233.
Yes, I sent him, but he wants a link because now he is out. He wants to attend the meeting through the address. Okay, sir. May I start?
Yes, please, go ahead.
Okay. Good afternoon, everybody. Today, I'm going to present my topic, characterization of triple superphosphate for removal of heavy metals. Before I started my presentation, I would like to introduce myself. My name is Muhammad Shapiu, not Shapiu, Shapiu Sulagarba. I'm from Niger. I'm doing a PhD in mineral processing in Dokuzi Elulu University. So my work is structured in 5 parts. Introduction, which I'm going to explain what is what is the meaning of triple superphosphate, the area of using, the objectives, materials and method that we used in our study, result and discussion. And finally is the conclusion I'm going to present. So what is the triple superphosphate? As we know, and the agriculture engineer they know, is an organic fertilizer. So triple superphosphate is made by phosphoric acid by adding concentrated phosphoric acid to phosphate rock. Its chemical name is monocalcium phosphate monohydrate. As we see here, the triple superphosphate we get from Gubretage company is granular form. So the chemical properties, as you see, water soluble is about 90%. Triple superphosphate is used in large area in agriculture, is used widely in agriculture area, but also is heavily investigated to the removal of heavy metals. You know, heavy metals is any metals which the density is greater than 5 milligram per centimeter cube. So the objective of our study is to determine the solubility rate and moisture content in TCP. Carry out heavy metals content in triple superphosphate by chemical analysis, because in the literature and previous study show that commercial triple superphosphate contain heavy metals as impurities. And finally, evaluated the effectiveness of PB and iron power metals removable by triple superphosphate. So from materials and methods, here what we did in triple superphosphate solubility tests, we worked different mass of triple superphosphates added to beakers, as we see here, containing 500 milliliters of distilled waters. So we mixers and adjusted the hot plates at 3,000 revolutions per minute within 30 minutes. Then the second step is the filtration through the filter paper. After that, the remaining solid we get from filtration was put it in dry oven here at temperature above 105 degrees Celsius within 1 hour. Then we took the samples after drying, put it in desiccators for cooling for approximately 10 to 20 minutes. So the solid colloid are wet again to take the final mass. As you see here is from 5 gram after solubility, we get 2.7 to 2.577 gram. For the most recent tests, we took 5 gram of triple superphosphate samples waved from balance and put in a dry oven at temperature 107 minutes. After 1 hour, the crucible with triple superphosphate were cooled in a desiccator and waved again. This procedure was repeated 3 times, as you will see in the next slide. So for the chemical analysis test, you take generally triple superphosphate fertilizers are analyzed by the agronomic association chemistry methods. So the modified methods, we use 5 gram of triple superphosphate in beaker 500 milliliters. Then we add 2 milliliters of hydrogen chloride in the solution and boil it at temperature 100 degrees Celsius. After 30 minutes, we took the boiled solution and evaporated near dryness. Then we filtrated through the funnel, the funnel containing filter papers. So the filtrates we took the sample to ICP analysis to determine heavy metals containing in our samples, triple superphosphate. So for the precipitation tests, as I said before, triple superphosphate solubility as is the first step in our experiments. So the triple superphosphate granular form, put it in water 500 milliliters within 30 minutes. So when TCP dissolved in waters, we added the pure metals, as we see in the pictures here. The color change to so when we put the pure metals, lead metals for precipitation test, as soon we added the pure metals, we take the samples 5 milliliters from 0 minutes to 60 minutes of reaction time.
I would like to inform you about the last 5 minutes, please.
Okay, sir. So here you see the samples. We put Then the final metal concentration we took here by atomic absorption to measure if there is a removal of our heavy metals. Here you see from the graph the results. We get 82% from 5 grams, and at 80 grams we get 63%. So what we can conclude from that, as the mass of triple superphosphate increase, the solubility rates decrease. Here we change the methods by varying the times. We took 20 grams. So you see, as we increasing the reaction time, the solubility rates increase. Here for moisture. So the result we get from moisture here is 1.42%, 1.70%. So approximately is 2%, which is slightly greater than the result obtained by De La Vega. For him is about 1.04%. So for chemical analysis, as I said before, commercial triple superphosphate containing heavy metals as impurity. Here you see from the literature, we compare the results, the average here from expect copper, cobalt, nickel, and lead. The concentration are in the interval of Charter's analysis. So from the maximum perceivable concentration, as you see, only PB is less than the others is above the maximum perceivability concentration. So from here for lead removal, lead and iron removal, as you see here, from the tables, from 0 minutes, we get 40%, and 60 minutes, we get 78.82% for lead. In the previous studies, by the immobilization of PB by phosphate rock, they get 65%. So we can say
Mohammed,
is more effective than phosphate rock.
Last 1 minute, and if you
okay,
can,
I will finish.
Your share screen.
Study demonstrated that the reaction for the ions, which provide the formation of insoluble at pH below 5.05. So coming to the conclusion, the solubility of triple superphosphate is about 82% in acidic condition, 3.3, and the moisture is about 2%. The chemical analysis indicated that triple superphosphate release heavy metals. And for the precipitation test result, we can say TSP with pure metals is effective for removal of PB and iron from the waters. This is the reference we used in our studies. Thank you for listening.
Thank you very much for your presentation. You are on time, but I'm sorry to say that we don't have time for question and answer. If some of you have any question in mind, please keep in touch with Mohammed. In privately, you can ask your question. Now we are going to start the second presentation of this session, which is in Turkish. Yüksek yoğunluklu polietilenin fiziksel özelliklerine çay ve karbon elyafın etkilerinin incelenmesi. I would like to invite Gözde Turan. Is Gözde Turan here? Gözde Turan is here. No, she's not here. So we continue with the following one. Now I'd like to invite Miss İzel Ok for her presentation. Her presentation is about the preparation and characterization of chitosan-based hydrogel reinforced by mesoporous silica nanoparticles. Welcome, İzel. Unmute yourself, İzel.
Okay. Hello, everybody, and I will share my screen. But yes, here. And hello again. My name is İzel Ok. I am master degree student of Nanoscience and Nanotechnology Department at İzmir Katip Çelebi University. And my supervisor is Assistant Professor Dr. Ahmet Aykaç. Today I will talk about characterization of chitosan-based hydrogels reinforced by mesoporous silica nanoparticles. And just a second, I will share, yes. And content, I will talk about the introduction, first of all, introduction and what is the hydrogel and chitosan-based hydrogel and mesoporous silica nanoparticles. And then I will pass aim of the study and experimental section. In this section, I will talk about the preparation of mesoporous silica nanoparticles and MSM chitosan-based hydrogel and their characterization. And then I will pass result and discussion, and finally, conclusion and future perspective. First of all, what is the hydrogel? Hydrogels are three-dimensional cross-link soft materials that are composed of large amount of water without dissolving or losing their structure. And they were first reported by Victor Lee and Lim in 1950s. Owing to this high water content, I mean typically between 70 or 99%, property hydrogels exhibit excellent biocompatibility, the capability to easily encapsulate hydrophilic drugs, and decrease the risk of drug denaturation and aggregation upon exposure to organic solvents, as well as the actin-like tissues. And in this picture, you can see what is the hydrogel, and it is like that. And hydrogels are classified into physically and chemically cross-linked hydrogels. Physically cross-linked hydrogels have secondary interactions such as ionic bonds and hydrogen bonding and hydrophobic bonds. And chemically cross-linked hydrogels have covalent bonds. That's why they are more stronger than physically cross-linked hydrogels. And in this picture, you can see these bonds, and the red ones chemical, and green and blue pointed ones are physical cross-link. And chitosan-based hydrogels. Chitosan is one of the most widely naturally occurring polymer used to produce hydrogel, and it is the structure of chitosan. Chitosan shows excellent biocompatibility, biodegradability, low toxicity, and antibacterial activity, and that's why chitosan polymer is considered as a promising candidate for biomedical application, especially as a chitosan-based hydrogel. On the other hand, there are some disadvantages like low mechanical strength, lose their 3D network, and another problem also is the releasing time drug. Releasing time of drug molecules, small molecules such as antibiotics from the chitosan hydrogel cannot be satisfactory. And that's why, in order to overcome these problems, various materials have been employed to form complexes with chitosans. And in this study, this material will be silicon nanoparticles. And mesoporous silicon nanoparticles, when we talk about that, there are many materials are used as drug carriers, such as liposomes, polymeric nanoparticles, dendrimer-based nanomaterials. Among of them, mesoporous silicon nanoparticles are considered as promising carriers. Mesoporous silicon nanoparticles are becoming popular due to their high thermal and chemical stability, good biocompatibility, large surface area, for example, controllable mesopore size. That's why they have provided new solutions recently in nanomedicine and biomedical application. I need to, yeah. In addition, MSNs have the ability to boast both the mechanical strength of the chitosan hydrogel and control the drug releasing time. This picture shows the classification of MSN, just example that. The first one is traditional one, the second one is modified one. Aim of the study, in the study we aim to create chitosan mesopore silicon nanoparticle composite hydrogels to address that MSNs are able to enhance the gel mechanical strength of the chitosan hydrogel after investigation of the cell structure and cell strength of the hydrogels. This picture determined the way what we did. First of all, we synthesize mesoporous silicon nanoparticles at the laboratory, and then we mix these nanoparticles and chitosan polymers. And after the freeze-thaw method, we obtained chitosan MSN chitosan based hydrogel. Experimental section, we used cetyl trimethyl ammonium bromide, STAP, and tetraethoxysilan, TIOS, ammonium hydroxide, chitosan, and acetic acid. The chemicals were supplied by Sigma Aldrich. Preparation of mesoporous silicon nanoparticles, MSN were obtained by doing slight modification in sol gel method. TIOS, STAP, ammonium hydroxide, and ethanol were mixed in the water solution. After the reaction, white precipitations were obtained and kept dried. And this figure 7 is a schematic diagram about the synthesis of MSNs. And this method is called swelling shrinking mechanism. In this mechanism, this mechanism was supported by the synthesis of MSNs with STAP. STAP as a structure directing agent and TIOS as a silicon source. STAP was firstly dissolved in water. After TIOS addition, it was solubilized in STAP hydrocarbon cores, and thus enlarging the micelles. Here you can see. When TIOS within the STAP hydrocarbon cores was completely consumed, the micelles shrunk and became smaller in size. And finally, we obtained mesoporous silicon nanoparticles. Preparation of MSN chitosan based hydrogel, and basically we add the MSNs into the aqueous acid, and then we dissolve the chitosan powder in this acetic suspension for 24 hours. The viscous solution was transferred into petri dishes and dried overnight, and then the semi-dried hydrogels were further dried in an oven at 45 degrees. And then hydrogels were pre-frozen at -20 degrees. And then the last step is lyophilization. And the samples were lyophilized in a freezy dryer. And after these experiments, we did some characterizations. And for that step, we use Fourier transform infrared spectroscopy, FTR, and dynamic light scattering, DLS, and scanning electron microscope, STEM. And then last we did swelling tests for both chitosan-based hydrogel and MSN chitosan-based hydrogel. Result and discussion. This graphic belongs to MSN, and here you can see OH bond peaks, and these peaks for carbon-carbon double bonds. And here 1000 2019 wave number pings belongs to silica nanoparticles. And here chitosan hydrogel without MSN, and here again we have OH bonds, and this one is carbon-carbon double bonds again, and these 1538 wave numbers belong to, okay, NH. Okay, I am going. And this graphic belongs to MSN chitosan hydrogel, and here NH peaks, and here silica peaks. And dynamic light scatterings of MSN, we use this analysis to determine the size distribution profile of small silica nanoparticles in suspension. Average distribution size is approximately 589 nanometer, and result quality was good. And here some pictures, and these pictures belongs to mesopore silica nanoparticles and MSN chitosan-based hydrogels. You can see the silicas on the chitosan matrix. And finally, swelling test of chitosan and MSN chitosan-based hydrogel. For swelling test after lyophilization, the samples were immersed in ultra pure water. Swollen samples were taken out for certain times, like 1 hour, 2 hours, and 24 hours, and then they were weighted. And the swelling percent was calculated using this following equation. And swelling rate, WS is the weight of the swollen hydrogel, and WD is the weight of the dried hydrogels. And here you can see the weight as gram unit. And this graphic data said that the swelling rates of chitosan hydrogels, the blue one, is very rapid because the first 1 hour it was swollen rapidly, but after the swelling rates, but after that the swelling rate decreases. Probably after 2 hours it reached a saturated point. On the other hand, MSN chitosan hydrogels, I mean the orange one, keep swelling for 24 hours slowly, and this proved that it can be used a good drug carrier and drug release applications because of the and due to the controllable releasing properties. And conclusion and future perspective, our investigations and studies on chitosan hydrogel and MSN chitosan hydrogels will be continued with more alternative parameters and characterizations. However, given that the data, we can say that MSN chitosan hydrogels have potential to be improved in terms of elasticity gel properties and antibacterial analysis, unlike the chitosan hydrogels without MSNs. And the result of this study will lead to further investigations related to drug delivery systems. And my references. And also, thank you for your attention. And before leaving the conference, I would like to appreciate my supervisor, Assistant Professor Dr. Ahmet Aykaç of Nanoscience and Nanotechnology, İzmir Katip Çelebi University, for being a great manager and such a helpful and reachable person all the time during my investigations. And thank you very much for your attention. If you have any question or suggestion, please don't hesitate to ask.
Thank you very much, Izel, for the nice presentation. Yes, we have about a minute. If you have a short question, maybe she can answer your question. Anybody has any question? Okay, so thank you very much, Izel. Now we are going to listen Mohammed Nasif Abbas with his presentation, remediation of nickel ions from contaminant since using mandarin pills as a non-whale biosorbent media. Mohammed, are you there? We are waiting for Mohammed.
Okay. Our research remediation of nickel ions from contaminated solution
We will let you to share your screen, actually. Now you can share your screen.
I will be trying. Website, photo, screen, box. Okay. Our research recommendation of nickel ions from contaminated solution using mandarin pills as non-viable biosorbent media. Heavy metal.
Excuse me, like this, it's going to be very difficult to see the screen. If it's possible to share your screen through your PC, it will be more helpful and it will be more effective for us.
There is some problem in my PC, therefore I would, there is no solution like even that.
So continue.
Heavy metal are considered one of the most harmful types of pollutant. One of the most important of these elements is nickel, which is used as raw material or auxiliary material in many industries and applications, such as batteries, stainless steel, alloys, gas turbine, coins. In addition to the use of the most catalysts used in petroleum refineries, vegetable oils, wastewater, which is discharged from this industry, must contain nickel metal of no more than 0.2 part per million in industrial water discharged to the river, and in the drinking water less than 0.02 part per million, according to the Iraqi specification. There are many conventional methods that deals with the removing nickel from wastewater, including adsorption, biological treatment, cationic exchange resin, chemical reduction, electrochemical treatment, membrane technologies, ion exchange, reverse osmosis, sedimentation, solvent extraction. Adsorption technology is considered one of the most important methods. It is a simple technology that does not require high cost or complicated equipment or pre-treatment. At the same time, it has proven its efficiency in treating heavy metal, especially with the use of activated carbon. However, the high cost of activated synthesis carbon and losing of 10 to 15% from weight after each regeneration process prompted researchers in the field of water treatment to search alternative medias that are used either adsorbent directly instead of activated carbon or as raw material in the preparation. Among the most important and well-known alternatives that have used interest are the horticulture waste because of the availability in large quantity, cheap price material, negligible toxicity, and apparent efficiency compared to the activated carbon. Experimental work A preparation of mandarin peels. The peels used in this study were from mandarin fruit crops, which was produced from Muqdadiya district farm, Diyala Governorate, Syrian of Iraq. After obtaining a sufficient amount of the collected mandarin peels were washed first with the excess of tap water and then with distilled water, and before boiled in water for 60 minutes to remove any impurities and that might be stuck with them during the storage period and to restore their freshness. After that, the washed peel were dried by two steps. The first one was naturally using sunlight and continued for 3 days in summer season, while the next step drying by oven for 24 hours at 50 centigrade to avoid the disintegration of the composition structure at high temperature to obtain a bioabsorbent material. The dried peels was cut into small pieces into small pieces range between 1 to 3 millimeter and used for their final shape without any further treatment. Figure 1 shows the mandarin peels used in this study. A preparation of nickel solution of 1000 parts per million concentration nickel ions was prepared in laboratory at 28 plus minus 2 centigrade by dissolving 4 grams of nickel hexahydrate. Figure 2, nickel hexahydrate and the stock solution prepared in this study. Calibration curve to indicate the concentration of nickel metal in aqueous solution after the completion of a treatment process. The AAS calibration curve of nickel ion was prepared through preparing multi-standard solution of different nickel ion concentration. The value of adsorbent obtained for each concentration was recorded. The relationship between the concentration of nickel ion and the adsorbent can be plotted to obtain the correction curve. The correction curve, when the relationship between two variables, the concentration, the adsorbent, is linear, of high correction coefficient, the concentration of nickel is the solution can be determined with a greater accuracy. Figure 3 shows the calibration curve using the atomic adsorption spectrum. Adsorption experimental. All treatment experimental were performed using a batch mode adsorption unit at different operating conditions. The percentage removal of nickel ions for contaminated aqueous solution after the end of a treatment process was calculated from mathematical relationship described in equation 1 and 2, represent the capacity mandarin peel to absorb nickel ions. Result and discussion. The process of treating aqueous solution contaminated with nickel ions prepared in the laboratory was accumulation by low-cost substance, which are Iraqi mandarin peels as bioabsorbent material using patch mode adsorption unit. The percentage removal of pollutant material was measured at various designing variables to determine the optimum condition that achieve maximum removal efficiency. Acidic function, pH, the effect of changing the value of acidic function of nickel contaminated solution with a range between 1 to 9, and by fixing the race operational variable constant at optimal value.
Last 5 minutes, I would like to inform you about
thank you. Figure 5 shows the effect of changing acidic function on the removing efficiency of the nickel ions on contaminated aqueous solution. It is noticed from the figure that the relationship between the pH and the removal efficiency has increased since the removal increased for 14.5% at pH equal to 1 to 86% at pH equal to 6. At pH value greater than 6, nickel ions in the solution will be precipitated in the form of nickel hydroxide, which is slightly soluble in water, and percent removal will increase. Therefore, the value of pH equal to 6 is optimal acidic function of nickel adsorption using mandarin peels. Agitation speed. Figure 6 represents the effect of agitation speed within the range between 100 to 500 RPM on the percentage removal of nickel ions. From the figure, it can be seen that relationship is directly proportional between 100 RPM up to 400 RPM. When they become steady and there is no change in the removal efficiency deposit, increasing the value of agitation speed. The agitation speed is always related to the diffusion of ions of the solution, as the increase of velocity lead to increase in diffusion. Therefore, removal value increase from 44.3% to maximum value 86% due to the increase to the speed from 100 RPM to 400 RPM due to the increase to the speed of diffusion nickel ions. Initial concentration. Changing the initial concentration of nickel ion in aqueous solution were carried out with the range between 1 to 100 milligram per liter. Figure 7 shows that the relationship is completely inversely between the removal efficiency and initial concentration. The increase in the initial concentration lead to decrease the removal efficiency as the removal rate decreased from 86% at initial concentration 1 milligram per liter to 40.5% at final concentration 100 milligram per liter. Contact time, the treating time, is the time required to adsorbent material to remain in contact with the pollutant ion dispersed in the aqueous solution to complete the process, adsorption process. The time interval ranging from 180 minutes, from 10 minutes to 180 minutes, keeping the other operation variable constant. Figure 8 indicates the increasing the contact time from 10 to 120 minutes, increasing the percentage removal from 40% to maximum value 86%. The efficiency of nickel removal remains constant.
I am sorry to say that you have lost 1 minute. Please be efficient.
Okay. I will finish at this time. And the reason for this due the active side to the surface adsorbent material. Adsorbent material media. Does the results represent removal efficiency obtained? Does the adsorbent media while other design variable constant will which increase the chance of adsorbent nickel ions and thus percent removal will increase also from 40.5% to 80.6%. Temperature, the effect of temperature is directly related to the chemical and physical process. The increase the temperature from 25 to 55 will increase the operational factor will fix. Increasing the temperature will improve the processing efficiency of nickel contaminated solution from 40% to 86% respectively. Conclusion, finally, the conclusion. This study draw attention with horticulture waste as a sensible source for many activities of horticulture, industrial, and environmental living. One of the most important conclusions of this current study is the raw mandarin peels are considered a material with high ability to absorb nickel ion as one of heavy, dangerous, and widely used metal of contaminated aqueous solution. The highest removal efficiency was 86.03% at initial concentration of 1
I'm
milligram
sorry to
per
say
liter.
that I have to stop you here because I gave you even 1 minute more. I informed you 3 times. Please complete. Thank you for your attention. Thank you for your
Thank you
presentation.
for your attention also. We preparation your cooperation with us.
Thank you.
Thank you.
Now I would like to introduce you Said Zabut for his presentation, Production of Recombinant Extracellular Domain of Human Epithelial Cell Adhesion Molecule in...
Yes, hello. Can you hear me?
Yes, we can hear you. Can you hear
Okay,
us?
that's great. Okay, so I will start and I will try to be summarized, and I will talk briefly. Wait a second. So can you see the screen now?
Yes.
Is it clear?
We can see. Continue, please. Try to be on time.
Well, to be specific, the production of recombinant extracellular domain of human epithelial cell adhesion molecule. These molecules, what is cell adhesion molecule? To be specific, I will give a brief information about cell adhesion molecule, what they are and what they are doing exactly. Cell adhesion molecule, they are the connection between the cells and each other. So they make the connection between them. There are 2 types, heterophilic and homophilic. Heterophilic, like there are some types of cell adhesion molecule like myosin, selectin, cadherence. So if two different types connected together from one cell to the other cell, like myosin and selectin, it's heterophilic. And for homophilic, it's if it's the same type connected to each other from different cells. So like here, like this slides. So here, if you see here this slide, this is selectin, and this is also myosin, and this is a different cell, and this is different cell. They are connected with each other, so it's a heterophilic interaction. But here it's a homophilic interaction. It is the same molecule. So what they are doing exactly, cell adhesion molecules, or specifically they call it CAMs, it's important as a therapeutic agent due to their function in the cells, because they make the connection between the cells and each other. So they have some functions for regulating the apoptosis and the inflammation and the blood-brain barriers as well. So in this research, I was producing the extracellular domain of one of the cell adhesion molecule types. It's called epithelial cell adhesion molecule. So epithelial cell adhesion molecule, it was discovered as a cancer diagnostic marker in epithelioma. Epithelioma means that the cancer which happened in epithelial cells or epithelial tissues. So when there is an epithelial cancer or epithelioma, these molecules in the cell increases much. It has like a kind of accumulation. So it was used here as a diagnostic marker. So to produce it, we should understand the genetic formation and how they produced. So here is the chromosome 2, and here is the exonic areas. There are 9 exonic areas which express the protein or epicam protein, epithelial cell adhesion molecule. So they are here from 1 to 4. They are responsible for for the extracellular domain and transmembrane domain as well. Transmembrane domain is 6 and 7, and 8 and 9, they are responsible for intracellular domain. I know it's a bit difficult because maybe most of attendants, they are not biologists or molecular biologists. And here is the structure on the cell. They are 314 amino acids. From this part, I produce this part inside the bacteria. And this is a transmembrane part, and this is the intracellular part. We are not interested for those two parts. We are interested in this part. And here is the location on the chromosome. On the chromosome B, the location is 2p21. And here is the techniques or downstream applications which we can use after production. So we can use them. We can produce like anti-EpCAM antibodies, anti-EpCAM, these molecules to inhibit the tumor, to be anti-cancerous. Or we can use it also as RNA aptamers. We can use it as immunotoxin. So let me jump. I will try to jump from this area because this is much. I will go for the material and the methods immediately. So here's the flow chart of the work. So I started with preparation of the cell lines, and after the cell lines, I extracted the RNA from the cell lines, and those cell lines of it was ovarian cancer cell lines and colon cancer cell lines. And after this, I made the cDNA library, and after we designed the specific primers. Which will make after this the amplification using the conventional PCR, and after this we restricted them using a specific restriction enzymes, and we used also a specific plasmid, and I'm going to talk about this as well in the next slides. And after this we ligated them with the plasmid vector, and we inserted them inside the bacteria to make the transformation, and the bacteria started to produce them inside it, and then we purified the extracellular or EpCAM extracellular domain from the bacteria using GST technique. So let me be specific fast here. So here is the first step, preparation of the cell lines. So we have two types of cell lines, and both of them ovarian cancers. And this is a component. It's a standard component for the preparation of the cell culture. And after we count them, we had here like we had 10 millions, and we have 5 millions from there's a OVCAR. And this is the second type of the cell lines. We have only 5 millions. And then we isolated the RNA from the cells using a triazole reagent. And it's a very famous reagent. As shown here, after using the reagent, we have 3 phases: the aqueous phase, the RNA, which we need, and the other phases, it's the DNA and the protein and the other lipids inside the cell, which we don't need. And RNA was precipitated using isopropanol. And after this, we washed with ethanol to get the RNA pellets at the end. And then we used nanodrop technique, spectrophotometer to measure the nucleic acid concentration. So we had here from the first cell line, we have a fair concentration, and also we have here a fair concentration. It doesn't matter, but it doesn't matter how much we have, but at least we have a fair concentration to continue our work. And then we made the cDNA library using random primers. And after this, we also measured the concentration of the nucleic acids after the cDNA. And after this, we designed the primers. I designed the 3 specific primers. Here, this is a gene of the extracellular domain. We designed the 3 forward and the 3 reverse. So this is the first one, the second one, and they have also reverse here. So this is the first reverse, the second reverse, and the third reverse, to be specific at the PCR reaction. So this is the primers which we used, and then we ordered them. We ordered them from Germany, and after ordering them, we measured the nucleic acid concentration. So we have also a fair purified nucleic acid concentration here, and then we jumped to their order. We ordered them with the cell here. So with the first cell type, we put the forward and the reverse one, and the forward 2 with the reverse 2. And then we, after the PCR reaction, we purified them using GeneJet PCR purification kit. And then we used gel electrophoresis 1%.
That you have last 5 minutes.
Okay.
On time.
Okay. So so what happened here? We found that that the primers has only expressed with 2780 SES here. So it doesn't express with OFCAR. So we don't have any bands here, but we have bands here. So we didn't get any bands here. So we dropped those and we continued with those two cells. And then we used the third primers, so to verify more, to check more. And then we got a strong band here. And after this, we digested using Zol restriction enzyme, which cut in specific areas, and this is also known for every biologist. And also we choose after this. We choose the plasmid called BGEX6P1, and we combine them with each other, or we digested them with each other, and we ligated them overnight. And after this, we transformed them to the competent bacteria, Escherichia coli bacteria. It was BL21 strain. And after this, we used colony PCR to check the positive bacteria, if the bacteria produced this protein or not. And we used also specific primers here. And we found that from our samples that we have I have almost like 60 different samples, but I used only 6 samples here. So the second sample here, I have a positive colony here, means the bacteria here has produced, and the bacteria in the 6 samples as well has produced the protein, the specific protein. And we measured after this, we measured the
I would like to inform
ratio.
about that. You have last 1 minute. Please try to cover your presentation.
Okay. So the point here that we finally we send after the production and after different types of PCR, we send them to for sequencing, and we found that we were able to produce it, but we were not able to be sure if this protein is functional or not. Why? Because we didn't get enough financial aid to continue our research, because molecular biology research is so expensive. So we couldn't be sure finally, and we tried a lot. We have here the first trial and second trial and third trial, and in each trial we have different ratios of this protein. So we produced it inside the bacteria, and this was human protein, and we were able to produce it inside the bacteria, and this was our achievement. So the next step, it should be to continue this research to produce antibody to work against this protein to stop the cancer or to stop the tumor. And here we go. Thank you so much. I tried to be fast, but to explain something that like that, I need at
Thank
least
you.
like
Thank
hour.
you very much. Those kind of organizations being on time, it's really important as well. As a young scientist, all of you, all of us, we have to pay attention to being on time and trying to fix our presentation to certain period of time. This is another ability, another talent of being scientist. Thank you for your presentation. Now,
Thank
we
you
are
too.
in continuation with the Shad Ali, virulence genes of methicillin resistant and methicillin susceptible staphylococcus isolates from diabetic food infections. If he's here, welcome. Shad Ali is here. Maybe we can wait a few seconds for Shad Ali. Okay.
Ahmet Hocam, I think he will not attend. We may end the session here.
Okay. Thank you very much for your attendance. Thank you for being with us. We would like to see all of you in upcoming symposiums, and for the next year, hopefully, we will be able to do by both online and the face-to-face meeting, maybe a hybrid meeting for the 5th International Student Science Symposium. Thank you for your attendance.